Bismillahirrahmanirrahim. Let's walk through a practical example to better understand how OPC works. Suppose we have the OPC server connected to a Modbus. There is an OPC server, and this is connected to a PLC, which is Modbus capable. And on the SCADA system, we also have a SCADA system. On the SCADA system, we have defined some a group or water level group. And this water level group actually contains 5 OPC items. Okay, so these are the 5 OPC items. So these are the 5 OPC items defined in this group, where the set point is basically the let's say the target water level. Control output CO is this is the signal which is going to the actuator. Okay, and then we have the process variable. The process variable is the in fact the actual water level. And then we have the low water alarm and the high water alarm. Okay, so these are 2 alarms. Now the SCADA acting as a client registers these variables, this group, and can read the current values of all the members. It can choose this based on 2 options. For example, either the timed interval or by exception. By exception means whenever the set point changes, for example, for a new target value, then it will send the data. So and also there is the HMI is able to write to the OPC server whenever the set point variable has a new target. Okay, a significant advantage here is like the key takeaway that we should mention here is like a key takeaway is basically uh, in simple terms, you don't you don't have to worry about the inner working of PLC, which is here having all the data to talk or any of the field levels or any field device. Okay, so this is the main benefit of it. So the OPC layer, basically what OPC is doing here. So here we see there the OPC layer abstracts that I mean the field devices and their data for clean and standard interface. Okay, so this is the main benefit of this. Next, we will see we will talk about some alarms and events in industrial systems. Alarms indicate basically the alarms or events, basically, they show abnormal situations. Okay, and that needs abnormal situations that need immediate attention, and there should be some actions. So OPC UA provides a standard way for the server to uh, notify the clients. Okay, so the servers, OPC servers, basically they actually they notify the clients whenever some alarm or significant event occurs. A client can connect to the OPC server, uh, browse through the available alarms or events, and subscribe to the and it can subscribe to those events in which it is interested. So these alarms can be tied to the specific OPC item or even to the server level issues. So once it is subscribed, so what happens is the clients uh, can subscribe to any alarm or event, okay, through the OPC items, uh, through OPC items. And once they are subscribed, these alarms are tied to the server and between the server and the client. So once subscribed, the server tracks all the events and maintains a list for the subscription. So this is the responsibility of the server. It is the responsibility of the server to uh, to track all events, and also to maintain a list of subscription, Okay, and whenever some alarm is triggered, so the server will notify all corresponding clients who are subscribed. Okay, so this notification and what this notification is has a type, the source, the event, the time and the event category, severity, and also the message. So this architecture ensures that the client receive real time in this architecture. So this makes sure that uh, the so let me write it, this alarm and event, this AE architecture ensures that clients receive real time alerts. Okay, real time alerts, ALERTS. Okay, without constantly pulling or worrying about the status. Okay, so without pulling, this makes it like more efficient and responsive. Now let's discuss the third OPC, the item in the OPC model, the OPC historic data access. This model is used when we want to retrieve the past data. Okay, so used when we want to retrieve past data from an OPC server. from an OPC server. Okay. So this server maintains, so that's why the server maintains a database. Okay. So the server has to maintain, uh, uh, it has to maintain a database base of the all the logged values, and basically doc values, we call them the OPC items. Okay. So some advanced servers even support some kind of like uh, mathematical operations. So here comes the variety of different OPC servers. We can say that some good OPC servers, they also do the mathematics. They can do some mathematical operations. Okay, just like on the historic data, and they can give us, like, for example, what is the average, minimum, the maximum for over a time window. Okay, and can return these values, can provide, and they can provide the values, these values, on request. Okay, of course, request from the OPC, from OPC client. Right. So the client connects to the server, browse the OPC items, and request the historical data based on its interest. So these requests are made over a time window specified by the client using the parameters like what is the start time, what is the end time, and also the resampling interval. So the data access can be, so this read operation or data sync access can be either synchronous or asynchronous, or even like a playback. So depending upon how the client wants to consume the historical data. Okay. So I will end here, because the next topic we will talk about the OPC unified architecture. Thank you very much.